Hi everyone. Next we are moving to the characteristics of sine wave. So in this particular characteristics of sine wave, we are considered, for example, some particular waveform. That waveform we can decide that sine wave or not with help of these characteristics. Let us discuss those characteristics. Before that, I will draw the. Okay, while you look at this particular waveform, this is a sine wave. So the following characters should be satisfied, then it is called as a sine wave. See those characters. The first characteristics, look at here. What is a time period here? This positive half cycle and negative half cycle, 0 to 2 pi or 0 to 360 degrees. The first case, it's one cycle spread over 360 degrees or 2 pi, then it is called as a sinusoidal waveform. So the first case, the first characteristics, the waveform should be spread over 360 degrees or 2 pi radians, then it is called as a sinusoidal waveform. That is the first condition, the first characteristics. Then we are moving to the second characteristics. Its polarity reverses every half cycle. By look at here, this the polarity is positive, this polarity is negative. That means its polarity, second point you need to note down, its polarity reverses every half cycle, then it is called as a sinusoidal waveform. That is the second case. Third characteristics, it has a maximum positive at 90 degrees and maximum negative at 270 degrees. Look at here. So at 90 degrees or pi by 2, we'll get the maximum, right? So we'll get the maximum, so call it as a V maximum positive. When you got to V maximum positive at 90 degrees, at 270 degrees, see here, 270 degrees negative maximum. So that condition is satisfied, then it is called as a sinusoidal waveform. In this particular waveform, it shows exactly the same. 90 degrees it is a positive maximum, 270 degrees it is a negative maximum. So it has maximum positive, value at 90 degrees and maximum negative at 270 degrees. Okay, so this is a third characteristics. Coming to the fourth one, the fourth characteristics, it has a zero value at 0 degrees and 180 degrees. So look at here, at 0 degrees, whatever the magnitude is 0. At 180 degrees, what is the magnitude is 0. That means at 0 degrees as well as at 180 degrees, the maximum value, the value is equal to 0. That is a third condition. So it has 0 value at 0 degrees and 180 degrees. Okay, so it value is 0 at 180, this is 180 0, and again 360 degrees also 0. That means this period, every 180 degrees the value becomes 0. Okay, that's what here. Next, coming to the fifth point, its value, it changes its value fastest when it crosses the zero axis. Very important. So whenever this 0 point, whenever the magnitude is 0, it crosses very speed. Okay, whenever it is a maximum value, it crosses very slow. Those are the 2 points you need to satisfy. So the first characteristics here, it changes its values fastest, very important, fastest when it crosses the zero axis. Next one, another point, whenever it is crosses the maximum maximum value, the speed will be less, that is a minimum speed. So it change will be minimum, so it changes slowly, changes its value the slowest when near its maximum value. Whether it is a positive or so. In this particular point, the waveform is changes. It changes the value slowest when it is near to the maximum, either positive or negative. Here two cases. It is maximum whenever it is positive, or negative, it is a very slow. The changes will be very slow. Whenever it crosses the zero, it changes very fast. That is another characteristics. So I hope that everyone is clear about the characteristics of sine wave, right? So then we are moving to the next topic, audio and radio frequencies. Okay, then we are moving to the audio and radio frequencies. In this audio and radio frequencies, so actually the frequencies ranging from 1 Hz to several megahertz, for example, the range. In between, we can classify two categories. The first one is audio frequencies. Audio frequency. Okay, we are call it as a AF. Second one, radio frequency. That is called it as a RF. Okay, so the particular ranges we are going to talk. The radio frequencies are those which can be heard in the form of sound waves. That means you are human being, we can hear the audio waves in the form of sound. For example, I speak in this particular video, we can hear that is the audio frequency. So here the point here, the audio frequencies are those which can hear, right, which can be heard in the form of sound, in the form of sound waves by human ear. Okay, next one. So the frequency range will be 20 Hz to, can hear, right, 20 Hz to 20,000 Hz. That means it is a very important point. What is a human ear sound is 20 Hz to 20,000 Hz. In between you can hear. Below that or above that we can't hear those particular sounds. Okay, so that is a point. Next one, the higher the frequencies, for example, the frequency is very high, what will happen, higher the pitch or tone, that particular tone of sound, that means higher the tone of sound. So in case of more than that frequency, so that is a point. Next one, in case of audio frequencies above 3000, for example, above 3000 Hz, in case of audio frequency, in AF, in audio frequency above 3000 Hz provides provides terrible, that means nonsense, that is a terrible sound, so terrible tone, whereas those below 300 Hz provide bass tone. Okay, so the ranges, soft tone or bass tone based on the frequencies. So next one, for alternating current above the audio frequency range, for example, above audio frequency range, the frequency range is above the audio frequency range, the variation, that frequency or call it as a radio frequencies, the vibration radio frequencies. In that radio frequencies, transmitted can be electromagnetic radio waves, that waves are transferred like a electromagnetic radio waves. Okay, those are the electromagnetic radio waves. So this is about the audio and radio frequencies. Radio frequencies is transferred which form? Electromagnetic radio waves. Okay, electromagnetic form. Then we are moving to the next topic, different values of sinusoidal voltage. Next we are moving to the different values of sinusoidal voltage and currents. So let us see what are the different values of sinusoidal voltage and current. First I am going to draw sinusoidal voltage. So this is the time axis as well. Okay, this is a voltage or current. The waveform we have, for example, the magnitude is 1. So everyone listen carefully. Here magnitude is minus one of the, definitely this is a topic, we will get one question from this topic. Okay, so here the maximum, for example, it is a current, it is a I maximum. Now this is a time 0, and then 90 degrees, 180 degrees, 270, 360 degrees. Okay, this is a, this is a peak to peak value, peak to peak. Now we will discuss all the different terminology. Now everyone is clear up to this. This is a sinusoidal waveform representation. Now the first point here, the first thing here, first one, instantaneous value. The first parameter is a instantaneous value. So instantaneous value. So let us see what is mean by instantaneous value. So instantaneous value means that in the particular waveform we can consider any point. In that particular point, what is the magnitude? That magnitude is nothing but an instant, that particular instant that magnitude is present. For example, this is a point, that is a magnitude is present in that particular case. That means instantaneous point is a number of points mentioned in the particular waveform. So all instantaneous points together is form the sinusoidal waveform, right? So in that particular case, the waveform is, for example, the waveform I is equal to Im sin theta. I is equal to Im sin theta. In that case, I want the waveform at the value at 90 degrees, I maximum. So here I maximum is equal to 1. So 1 into sin 90. Sin 90 is equal to 1, that is a 1 volt. So what is the maximum value in that particular instantaneous? 1 volt. So in that particular instant the value is 1 volt, like that. The instantaneous value means that in the particular phase angle, what about the magnitude? That is the instantaneous value. Okay, clear? So in that case, this is the instantaneous value at 270 degrees is a -1. The instantaneous value at 90 degrees is a +1. The instantaneous value at 0 degrees is a 0. The instantaneous value at 180 degrees is a 0. The instantaneous value at 360 degrees is 0. That means this is about instantaneous value. Okay. Next we are moving to the second important parameter, that is a peak value or maximum value. Peak value or maximum value. So peak value or maximum value, so it is the highest value reached by the current in one cycle. Okay, it is a highest value. It is the highest value reached by the current in one cycle. That is nothing but a maximum value or instantaneous value. In that particular case, in this particular waveform, what is the maximum value? The maximum value here, this is the maximum value or peak value. So whenever current reaches to the maximum value at 90 degrees, this is a peak. This is also called as a peak value. Okay, all of you got my point. You got idea about the maximum value as well as instantaneous value. In that particular case, the maximum value, two maximum values are present. What is the first case? At 90 degrees, what is the maximum value? +1 ampere, for example. At 270 degrees, what is the maximum value? The maximum value is a -1. For example, it is a current, it is amperes. If it is voltage, volt. Okay, in that it is not a volt, it is a ampere. I am consider the ampere case, current case. Okay, clear. Next, third one. Third one is a peak to peak value. Peak to peak value. Just understand the concept. That is enough. Okay. The peak to peak value is nothing but it is a sum of. So it is a sum of. It is a sum of the positive and negative peak values, usually written as a peak to peak value. Is it okay? So coming to here, the peak to peak value is nothing but it is a sum of the positive magnitude and sum of the negative magnitude, both together. It is a peak to peak value. Here peak to peak value is a 2 amperes. 2 amperes, that is a peak to peak from this particular peak to this particular peak value. So here peak to peak value in this case, 1 plus 1, that is equal to 2 amperes. Just now I mentioned here the peak value here 1 ampere. Here peak it is a positive peak, negative peak is 1 ampere, peak to peak is a 2 amperes. Okay. Next, all these points are very very important in the case of third and fourth unit transistors. Also these particular concepts are very very important. That's why everyone listen carefully. Next, second one, fourth one, RMS value. That is called as a root mean square value. RMS is nothing but a root mean square value. Okay, I will tell you what is exactly root mean square value, but in the examination you don't want the definition. Okay, definitions they will ask in case it by chance is there, but concept and formulas are important. That's why I will give directly to you RMS value concept. First of all, see what is mean by RMS value. Let me take, this is a resistor. I connected this particular resistor to DC supply, for example. Okay, this particular resistor current will be flowing, definitely heat will be generated, that is I square R. Okay, so that is a heat losses, right? In the same circuit I disconnected this particular battery and across these terminals connected across these terminals. Now that is AC, sorry, across connected, we are replacing this particular voltage source connected across AC. Okay, whenever you are connected across AC supply, again the heat losses will be I square R only, that is a heat. In the both the cases, the heat will be generated as the same. So regarding the root mean square value is nothing but the root mean square value whenever DC supply is connected to the particular circuit, particular resistor or element, the heat will be generated same as if you are connected AC supply to the same circuit for the same time, you are connected the particular circuit, it generates the same amount of heat. That is called it as a root mean square value. That is a theoretical definition. All of it clear? Now coming to the root mean square value form. Root mean square value, also call it as effective value, that is a IRMS. In case of current, IRMS is equal to I maximum, already know maximum value, I maximum by root 2. This is for sinusoidal waveform, that is also important. This is for sinusoidal waveform. Is it okay? All of it clear? What is the root mean square value for sinusoidal waveform? Im by root 2. Okay. Next, coming to the average value. The fifth topic is a average value. So here the average value. So it is average value is nothing but arithmetic sum of all instantaneous value of a one half cycle is nothing but a average value. So it is average value is nothing but it is arithmetic arithmetical average of all instantaneous values in one half cycle. In one half cycle of the waveform. Okay, that is nothing but a average value. The average value for alternating waveform, that is a sinusoidal waveform, will be I average is equal to 2 Im by pi, that will be equivalent to 0.637 into Im. Everyone remember these two formulas. For this is for sinusoidal waveform. That is important. Okay, so all of you got about average value and RMS value. Now my question is, in the examination, how to remember this average value for different waveform, because they won't ask only sine wave, they will ask the different waves. That's why I will give the one tabular column. You are preparing for competitive exam, right? In the competitive exam, the examiner maybe think in the different way, like we are preparing for the sine wave, average value and RMS value, they will ask for triangular wave, they will ask for sawtooth wave, they will ask for square wave, they are asking for the possibility is there, right? That's why I will give some tabular column to you, so everyone remember this tabular column, note down that. Okay, so that is a different waveforms for average value and RMS value. The first one is a waveform. Okay, second one is a what is the average value and what is the RMS value. I will give all the waveforms. First serial number 1. In the first serial number 1, sine wave. The waveform is a sine wave. Sine wave average value, just now we discussed the average value 0.637 into Im. Okay, for example, this is a I, small I. So that is Im. In case of RMS value 0.707 Im. Is it okay? So coming to here, 1 by root 2 is nothing but a 0.707. 1 by root 2 is nothing but a 0.707 Im. This is also the formula. Okay. In case examination, they will give the options like in the form of this particular options. Maybe this is the formula 2 Im by pi. In case in the examination they will ask, this is a Im by root 2. All of it clear? Next we are moving to the second. In the second waveform will be triangular wave. This is the triangular wave. So for triangular wave, what about average value? What about RMS value? We'll see. The average value of the triangular wave is Im by 2. Okay. The RMS value of triangular wave is Im by root 3. Clear? Next, third one. Third case. In the third case, square wave. You'll see square wave. In the square wave, okay, this is a square wave representation. For the square wave, the RMS value and average value both are same, that is Im and Im. Maximum value as well as RMS value both are same. Next one, fourth case, sawtooth wave. This is a sawtooth wave, right? In that sawtooth wave, same as triangular wave, the same formulas here, Im by 2, Im by root 3. Okay, this is about the different average and RMS value for different waveforms. So everyone note down in your running notebook, and then just these, any one maybe numerical problem will come, otherwise directly they will ask the formula. Whatever maybe you don't know, but you know this concept you need to remember. Definitely you can answer any question from this particular topic. Okay. Okay, next we are moving to the third one, form factor. So that is the sixth one. Okay, form factor. So for form factor, it is a ratio of, it is defined as it is a ratio of RMS value to the average value. Okay, so that is represented by the Kf. So Kf is equal to, what is the RMS value for sine wave, for example 0.707 Im. What is the average value of sine wave? 0.637 Im. So finally, what is the form factor now? 1.11 for sine wave. Is it okay? So this is about the form factor. So it is also very important. The form factor value is always constant for different waveform. For example, sine wave, whatever amount you are given, average or RMS value, you will get the form factor is 1.1. That is a constant. Okay. Next, seventh one, crest factor or peak factor. Crest or peak factor. Okay. So let us discuss the last one. Okay, so here it is a ratio of, it is ratio of maximum value to the RMS value. Okay, you know, it is represented by Kc. What is the maximum value? Im. What is the RMS value? Im by root 2. That will be equivalent to 1 root 2. That will be equivalent to 1.414. So that is a crest factor or peak factor. Is it okay? It is for sine wave. So this is about this particular topic. We ended this section still crest factor, but I will give the one assignment to you. Everyone, those are subscribe our course. We have a separate Telegram channel, right? In the Telegram channel, everyone post these particular answers. I hope that everyone are doing best. The values of form factor Kf, the value of peak factor Kc. So for sine wave, what is the form factor? For cos wave, what is the form factor? Triangular wave, what is the form factor? Square wave and sawtooth wave. Everyone calculate. For sine wave already we did, right? So form factor for sine wave is 1.11. Peak factor for sine wave is 1.414. Likewise, you can calculate remaining parameters and then send it to, this is assignment for you, send it in your our Telegram group. Okay, then I will verify that whether it is correct or wrong. Okay, this is about the explanation related to the total entire this particular video. Next video we are moving to the phase on AC phase difference. Okay, thank you.